over your last few slides for this unit 11. So we're going to have acid and base reactions, and we're also going to talk about strong and weak acids and bases. So here we go. Neutralization is a word that you will see every once in a while. It's an acid-base mixture. The resulting mixture is not as acidic or basic as the solution that you started with. So when you're trying to make something neutral, that means you have a little bit of acid, a little bit of base, and your results have more of a neutral pH, so 7 or 8 on the pH scale. Each salt listed in this table is formed by the reaction between an acid and a base. So sodium chloride, that's salt, right? We use it to flavor food. Potassium iodide, that's another thing that we use in salt sometimes. Calcium chloride, we use that when it gets really icy outside. We spray that or pour it on the sidewalk or the road. Potassium chloride is sometimes used as salt. Calcium carbonate is what's found in limestone and seashells, and then ammonium nitrate is fertilizer, and it's also used in like ice packs. So each one of those is a salt, but the formation of that salt is a reaction between an acid and a base. So really just know that a lot of salts are acid-base reactions. Our last section of notes is on strong and weak acids and bases. Remember that an acid is anything that donates a hydrogen, so it's wanting to give that hydrogen away. A strong acid dissociates completely in water. So we talked about this a little bit when we were talking about electrolytes. Dissociates means it's going to completely break apart. So let's say you have hydrochloric acid, which is HCl. That H and the chlorine atom completely break apart or completely dissociate in water. This makes it a very strong electrolyte. This means they release all of their hydrogen atoms, which are protons. They donate those. They want to get rid of them. An example is what I just said, hydrochloric acid. It releases all of its hydrogen when placed in water. So it becomes H on one side, chlorine on the other side. A weak acid is an acid that dissociates some, releasing only some of its hydrogen atoms into the solution. So it's less capable than a strong acid at donating protons. It's just going to donate a few, the other ones are going to stay together. So an example of that is CH3COO negative plus H. That's what it becomes when it dissociates. So it keeps some of those hydrogens, gives some of them away. Remember that a base is anything that accepts a hydrogen. So acids give those hydrogens away, bases accept those hydrogens. A strong base dissociates completely in a solution, just like a strong acid. It's going to completely break apart. They are grabbing onto those protons or those H plus ions. An example would be potassium hydroxide, KOH. It dissociates or breaks apart and it becomes some potassium ions and a few hydroxide ions. A weak base does not completely dissociate in water, so it breaks apart sometimes, but not all the time. An example would be NH3 plus H2O. So ammonia, which is NH3, is a base because it accepts H plus ions. It does not come completely apart, so sometimes it gets rid of one of those H's, sometimes it keeps them. All right, guys, that's all we have for acids and bases, and that finishes up Unit 11. Hop on to office hours if y'all have any questions. Bye.